Well, hello there, and good morning, good afternoon, or good evening, depending on where you're joining us from today. Welcome to Engineering for Change, or E4C for short. Today, we're very pleased to bring you the latest in E4C's 2013 Webinar Series. Today's webinar is developed in collaboration with the Frugal Innovation Lab at Santa Clara University, and our presenter is Professor Radha Basu. My name is Yana Aranda, and I'll be moderating today's webinar. When I'm not doing this, I work with the American Society of Mechanical Engineers, or ASME, where I am the Senior Program Manager in the Engineering for Global Development Department. I'd like to take a moment now to tell you a bit about today's webinar on the subject of sustainable solutions for emerging markets at the intersection of technology, innovation, and livelihoods. At E4C, we're constantly on the lookout for innovative organizations that are developing extremely affordable technology-based solutions. So we're especially excited to have the Director of the Frugal Innovation Lab at Santa Clara University and CEO of IMERIT, Radha Basu, join us today to share some of her work and learnings to date. Thank you for being with us, Radha. Before we get rolling, I'd also like to take a moment to recognize the coordinator of the E4C Webinar Series. In addition to myself, we have Holly Brown and Victoria Chung, and Alex Torres of IEEE, who work on and delivering the webinar series. As always, thank you, team. If anybody out there has questions about the series, please be encouraged to contact us via the email address visible on the slide here, webinars@engineeringforchange.org. Before we hand things over to our presenter for today, we thought it would be a good idea to remind you all about Engineering for Change and who we are. E4C is a global community of now over 30,700 technically minded individuals such as engineers, representatives from NGOs, and social scientists who work together to solve humanitarian challenges, whether in water, energy, health, agriculture, sanitation, or other areas faced around the world today. We invite you to join E4C by becoming a member. E4C membership is cost-free access to a growing inventory of field-tested solutions and related information from all the members of our coalition, including professional societies as Engineers Without Borders USA, IEEE, ASCE, and ASHRAE, as well as academic supporters such as ASU's Global Results, Santa Clara Center for Science, Technology, and Society, international development agencies like USAID and Practical Action, as well as access to a passionate, engaged community working to make people's lives better all over the world. Registration is easy and it's free. Check out our website, engineeringchange.org, to learn more and sign up. The webinar you're participating in today is one installment of the Engineering for Change webinar series. This free, publicly available series of online seminars showcases the best practices and thinking of leaders in the field, bringing leading-edge technology and solutions to bear on global humanitarian and development challenges. Information on upcoming installments in this series, as well as archived videos of past presentations and supplementary information, can be found on the E4C webpage, listed here on the slide. We also have information on our YouTube channel if that's easier for you to access. If you're on Twitter, I'd also like to invite you to join the conversation today with the hashtag E4C Webinars. Our next webinar will be on June 27th at 11 a.m. Eastern Standard Time with Rebecca Richards-Cordham, who is the chair of bioengineering at Rice University and co-founder of a tremendous program called Beyond Traditional Borders. She will be speaking on engineering performance, low-cost technologies to improve healthcare in low-resource communities. To register, please visit the E4C webinars page. It should be a really interesting and exciting webinar. Now, a few housekeeping items before we get started. Let's see where everyone is from today. In the chat window, please type your location. I'm going to go ahead and show you what I mean by keeping in mind. Everybody should be seeing that. Please do let us know where you're from. It's really great to see where everybody is joining from. Any technical questions or administrative problems should go into the same chat window. Feel free to send a private chat to Holly or myself with a specific question. You can also use the chat window to type in any remarks you may have. During the webinar, please use the Q&A window, which is located below the chat window. Type in your questions for the presenter. That way we can keep a track of all the questions. If you're listening to the audio broadcast and you encounter any trouble, try hitting stop and then start. If that does not work, you can use the call-in number for the teleconference. You may also want to try opening WebEx up in a different browser. Looks like we have folks from all over today. I see folks from Germany, from all over the United States, the Netherlands. Very cool to have you all here with us. So let's learn a little bit more about our presenter today. Today's presenter is Radha Basu, and she has had significant impact on the Indian software industry, as well as development of women in technology. Actually has spent 20 years working at Hewlett-Packard, and then in the mid-80s started HP Software Center of Bangalore, and the HP TCS joint venture. Radha has blazed the trail for other women executives while also mentoring young girls in science and women professionals in the technology industry. From July 1999 to May 2006, Radha held the position of CEO of the NASDAQ-listed company SupportSoft, leading it through its initial secondary public offerings and building it into a worldwide market leader in support automation software. After retiring as CEO of SupportSoft, Radha and Deepak created a global social enterprise, the ANUDIP Foundation. The goal of ANUDIP is to generate livelihoods for the unemployed and marginalized in India by developing entrepreneurs and empowering them with access to markets and capital. Today, Radha is both the director of the Frugal Innovation Lab at Santa Clara University School of Engineering, as well as the CEO of IMERIT, a social enterprise branch from ANUDIP. It's a tremendous amount of experience, and I'm very thrilled to have Radha with us today. So I'm going to go ahead and turn it over to her for the presentation.
Good morning, and hello from the Frugal Innovation Lab at Santa Clara University School of Engineering. I'm delighted to be speaking with all of you. If there is an organization that represents the use of technology and engineering for global development, it is this organization. It's Engineering for Change. And we are so delighted to be partnering with you and to be speaking with all of you. When we set out to do the Frugal Innovation Lab, we were really looking at how do we, as a university, as an organization, how do we look at doing engineering with a mission, which is something that the Dean of the School of Engineering and the faculty and students really believe in. Because Santa Clara University is sort of at the nexus of Silicon Valley and social justice. And Silicon Valley is about innovation and entrepreneurship. But we also realize that innovation and entrepreneurship happens all the way, every place in the world, and particularly when we're looking at sustainable solutions and emerging markets, it's really important to look at technology and innovation from the viewpoint of how does it impact global development. And that was sort of the impetus of the Frugal Innovation Lab. So I am going to move on here. So why do we go to emerging markets? And this looks less of an engineering slide and more of a business slide. But I think it is really important, and was something we believe in, that business success and market success have to be in conjunction with innovation, even as we look at technology and innovation for social good. Because if it does not make market sense, then that word sustainable and the other word that goes with it, scalable, does not happen. So this is a slide I use with a lot of MBAs and corporate executives who say, well, my CSR people will work with you. And I really want to make the point, and I think Engineering for Change is very much in the middle of that. is to make the point that the emerging markets, if you look at the slide, the share of worldwide GDP of emerging markets, look at the one that's going from bottom up, actually crosses over from the developed market somewhere in the 2016-17 time frame, actually about 1 or 2 years ahead of time, which means that all of us engineers better be prepared to be innovating solutions and technologies for these emerging markets. And what is important in these emerging markets is a ubiquitous mobile population, a very young workforce. For example, in India, where I'm originally from, it's 26 years old is the average age of the workforce, of at least the documented workforce. Mobile phone subscribers, I don't even need to tell you about, and have another slide on it. But look at things like forex reserves, exports, foreign direct investment, inward FDI, outward FDI, and the number of Fortune Global 500 companies. This slide is about 1.5 years old, and now that has gone up to almost 40-some% is coming from the emerging markets. Now, when you look at the needs of emerging markets, they are different than what we are used to in the developed world, which is what we have been. It's that for the top layer of the pyramid, or I invert it and look at it as the bottom layer of the pyramid that we've been designing for. So if you look at what is happening, it's maximizing in one of the areas mobile for development. The pace at which mobile phones have spread globally is unmatched in the history of technology. I do a lot of work in rural areas in India and Bangladesh, in South Asia mainly, and I am absolutely amazed and stunned, even though this is the world that I live in, about the mobile is no longer a phone. It is a life tool. It's a life tool used for water, clean water, looking at healthcare, looking at energy systems. All of these things that we need and are critical for addressing problems in the emerging markets. And note, I don't say base of the pyramid. It's not a term I really like, because if the base of the pyramid is more than 60%, who says what's base and what's on top? So there are more than 6 billion mobile subscriptions worldwide, and it is an amazing way that the mobile technology and the mobile as a device is being used. And when I travel a lot, I get funny comments like, and this really sometimes I think dates me. I was in a remote village in eastern India, and this young lady, and I was kind of struggling with my email, and this young lady says to me, Didi, which means older sister, you still use email? She said. And so you realize that social media and SMS and the mobile are really taking over also communications. So with that as a background, what is it that the Frugal Innovation Lab focuses on? It's about accessible, affordable, adaptable, and appropriate technologies, products, and solutions to address human needs in emerging markets, because emerging markets are about technology for human needs. And you have to make sure they can be, all the people can access them, at least the next tier of the pyramid of the population. It's affordable. So frugal doesn't mean cheap. It's affordable, it's adaptable, and appropriate. We can adapt our technologies we've used different parts of the world to the needs there, but they have to be adapted properly. And that is the mission. Well, we can be in a lot of areas, but we try to focus, and even this is broad for a little organization like ours. And the technologies we focus on are mobile devices. Again, don't say phones, but devices, and I'll share with you why. Cloud platforms, slowly getting into 3D printing, which is starting to pervade a lot of the emerging markets. And the needs areas are clean water, global public health, and renewable energy. So this is the area that we focus in. Okay, this next slide is something that I would say is sort of the foundation of how we have a number of courses. We start with every freshman engineering student goes through one module of Frugal Innovation, both in lecture and lab. We have courses that go through juniors into seniors, lots of senior design projects, which is a 10-month project for us for seniors to graduate in the School of Engineering. Many of those projects are in frugal engineering, and then we have graduate courses in engineering for the developing world, mobile apps and instrumentation, frugal energy technologies for public health. So we have a series of almost 18 courses and programs throughout the engineering school. So it's really immersed in this whole area. But very key to that are two principles. One is these frugal core competencies, which means that when people think frugal, they think cheap. But we talk about rugged, and each of these 10 core competencies have case studies, multiple case studies. And if you come into the Frugal Lab, and we invite you to come and visit whenever you're in Silicon Valley, or we can give you a virtual walkthrough, you will see projects in each of these areas all plastered on the wall and posters. And so, rugged, have to design products and solutions that can operate in 50, 52 degrees. I was actually in 54 degrees C last year, and down to minus whatever. Have to be human-centric. People who work in these areas, you have to make it possible for them to use not just simple, but really have the empathy as to how these are used in the field. Simple is one of them, using local materials, making them affordable, and we talk about like case studies like the Jaipur Foot, but most of these case studies, I would say 90% of them are projects that we have worked on. Green technologies, making sure that they're renewable technologies, whether you use solar power to be able to do a refrigerator or to be able to bring power into emergency rooms, but be able to use green technologies. Lightweight, to be able to carry around things in a rucksack, in a backpack, and take them around so field health workers can use a backpack, an ultrasound machine in a backpack. Adaptable. A lot of the work we do are not, new stem cell research, but being able to take existing technologies, but very state-of-the-art technologies, like using a nano silver layer, colloidal silver layer for clean water, for water filtration. And then two extremely critical things. Last mile distribution. If all we did was technology, innovation, and solutions, we would not be able to get the solutions out. So a lot of the innovations are in the distribution model and last mile distribution, like using Avon model. Those of the people on the webinar who are ladies might have heard of this Avon style of distribution, using women to be able to take products out. And so some things that have last mile distribution, using ASHA workers in India to take healthcare solutions out, or using solar sisters in Africa as a model. So last mile distribution and innovation in that becomes very, very critical. And that's another one where E4C, I think, can play a really important role. And lastly, I think of mobile as a foundation technology, not so much just one of the core competencies. Whether you're working in agriculture, health, water, fair trade, mobile becomes an important device. So let me go on, because I want to go on to some of the case studies. The other thing that we are using is we really look at the design innovation process, and thanks to Stanford C-Lab, where they've, innovated the design innovation process. And really critical as we work with students and engineers and corporations, because we do workshops for corporations as well in frugal innovation and engineering for emerging markets. The steps of empathize, define, ideate, prototype, and test. I grew up doing a lot of design, Hewlett-Packard. I joined in HP Labs, and I worked in Silicon Valley, but also many parts of the world. And oftentimes we would look at what was called the next bench syndrome, which is looking at engineers like yourself, and then you're designing some wonderful, doing research and technology. But when you're working with emerging markets in the developing world, it's really important that is looking at the empathize, define, ideate, prototype, and test. So really, really look at being able to empathize with the people in the field and understand what their needs are. So some of the examples that I'd like to look at are in mobile money, agriculture, livelihood development, medical devices, clean water, sustainable energy, and hybrid business models. So I would like to, I believe we can do a poll. How many people are really familiar with the use of mobile money and how that has, somebody like an M-PESA and now handling 67% of the money transactions in Kenya. How many people are familiar with these examples? It'd be nice to get, it's very hard on a webinar to know who you're speaking with, and it'd be nice to get a nice poll on this. Maybe I don't know how to poll. Okay? Okay, not familiar. Familiar. All right. So it's kind of a good good mixture. I'm just giving you guys a little bit of Okay, so I'm going to now go into a few case studies, and then in these different areas. So one that I would like to start with. So we use the 3 I's in this whole Frugal Innovation Lab, and the I's are instruction, innovation, and immersion. And these 3 I's are a very critical part of how we bring things together. The instruction piece I already talked about, a large number of courses, and we feel that for students and for corporate employees, a number of our students are from local corporations like Cisco, Intel, Lockheed, etc., NVIDIA, Qualcomm, that it's not enough to just have the instruction. It should be looked at both from an immersion. So we work with a large number of social enterprises through the Center for Science, Technology, and Society and their Global Social Benefit Incubator platform, and the tech laureates who are, we come across them every year, and we work with a number of social enterprises worldwide, which gives us the immersion into what we call real-world solutions. And the third piece is the innovation. This particular example of the clean water is it's using an electrochemical detection of arsenic, and it's using a paper-based microfluidic device that to basically look at affordable clean water water quality monitoring. And so if you will see, and these will all be up, so I don't want to get into too much of the details, but basically it's being developed by students in the bioengineering department of Santa Clara University, and it looks at taking a water sample, and it forms a barrier, a hydrophobic barrier for the water sample that it flows along. And then there is a conductive ink that it's you actually look at it and you actually use it over select specified locations, and then have you put over it silver chloride over the reference electrodes, and then that's the preparation of the device itself. And then you use basically electrochemical detection results, and you can see at the bottom the paper, the cell, and the plastic. So you can look at it whether you're using hazardous effects of arsenic exposure from drinking water, which can include cancer. It can look at it can cause thickening and deterioration of arteries of the skin, and elevated risk of heart disease itself. So the first step is a solution to arsenic groundwater is the detection of the samples and accurately determining if the WHO levels are, whether it's below or above, and being able to map them. And then if you take this, so think of this as the paper-based microfluidic device which actually maps the arsenic. And if you then take it to my next slide, and I'm spending less time on this and actually going into the next slide, which is, and I'm sorry, I should have taken off the water filter mark across that. But if you take it to the next slide, what this is showing is the fact that we can do the detection of whether there is arsenic or not, or other kind of E. coli or other water issues. But then look at the next piece where there is and there are a couple of ways we do the water detection of pathogens in water. This particular one measures electric properties of a DNA sensor. That's the sensor part. Then we moved on to condition the sensory data to detect water pathogens. Then we send the information, which is the electrical signal generation, signal conditioning, and data transmission, and we send that to a smartphone, actually to an Android, for analysis. So what I want to show here are three groups of people working together. Bioengineers on the sensor side, electrical engineers on the electrical interface side, and COEN or computer engineers who are able to take the application actually does the graphing, etc., and then is able to map it onto a Google map, so you can actually take the sensors and test different levels of pond water, and then map it into a Google map and actually capture that on a cloud platform. So all I want to show here is not so much the technology as the fact that there are bioengineers, electrical engineers, and COEN engineers working together. And this is actually an example of innovation because we're looking at productizing this. Actually we're not yet productizing, we're building the prototype to take to the field, work with field-level social enterprises, and then look at the results, modify them, and actually look at productizing it. So this is an example of innovation. Now let me go on a bit more and talk about one where we're working with a social enterprise in the field called M-Farm. And the M-Farm is a system to provide farmers with information. It's an Android application. It's in Kenya. And this is one where our students and faculty are working with a social enterprise in the field, mobile in agriculture. They came to us last year and said, well, we have the social enterprises there, and we're connecting with the farmers. Well, we really don't know how to use Google ODK Kit and be able to do all the programming. We don't even know what we can collect and what we can use in the cloud platform to create a database. So we have created this application for them. So this, I would say, is an example of immersion. Provides farmers with up-to-date market information, links farmers to buyers through a marketplace, is now connecting it into mobile money, but also importantly providing current agri-trends for farmers to be able to use it. This is very much utilized in the field through the social enterprise, an example of how the immersion part works well. We have students traveling there. We had the social enterprise, the entrepreneur, actually come to Santa Clara last summer, spent 2 weeks with us as part of the GSBI, and we have worked with them for the last 10 months, and it's also a senior design project. And actually now we have a graduate student working on it in the lab. But look at some of the things that we have used that are coming from the market, which is an example of Nokia's what's called the Life Tools platform. And Nokia is looking at, and we're interfacing with this, looking at agriculture. They have the Life Tools consist of agriculture, entertainment, and education. The potential, the market prices, the input prices, the weather, information and tips, these are examples. I'm showing this to you from Nokia because these are examples of ways in which farmers can use them. We happen to be working on the one set of things with M-Farm because every country is different. We've looked at solutions like eChopal from India, the Nokia Life Tools, and we're working with the farmers for this particular set of things. I'm going to respond to one thing, and I don't know if this is the proper way to do it, but there is a question, very good question on the water monitoring, which says you focus on the technical aspects. How do you plan to bring this product to market, i.e. to replicate and scale it? And I think this is one of the most important questions. So if everybody's okay, I will take a moment to actually respond to that before we go on. So there are three parts to, so as you saw, the empathize, define, ideate, prototype, and test. I think we've gone through the empathize, define, and ideate, and we're building the prototype. The first thing we will do is to take the prototype to the market. An important part of our go-to-market is to work with field-level social enterprises. So we have 3 social enterprises in the field that we'd be working with, including a university-level group in eastern India and Bangladesh, where the arsenic levels are very, very high, and that's part of it is for arsenic monitoring. And then we will test it in the field and test other kinds of water pollutants as well, and actually go through checking out the prototype. Then we are looking, we've got the software application already there, so it's all the technology part. We look at, we've made a few grant applications to look at building a sensor that are not grant, I would say corporate partnerships is a better way to put it, to actually look at how we can build a sensor to be a miniaturized sensor that can maybe even fit into, it's like a SIM card in a phone, but it's attached to a phone. If you know devices like CellScope, which have the phone and the product. Then, in terms of the go-to-market, I think one of the best partnerships we have, and you guys are probably aware of this, is NetHope. NetHope is a consortium of 39 of the world's largest nonprofits. And they are very good in being able to work with the nonprofits to take technologies and products to market. And a large number of them, and a number of them have large number of healthcare workers in the field. I mentioned one of, and are working with many, with CARE, CRS, etc. And we will start to actually use that kind of a model to see whether these products work. So some of it is testing. We also work with social enterprises like e-health points that have that are set up, and that's actually a for-profit social enterprise that has rural telemedicine where these products can be used. So we're looking at a combination of both. E-health point. NetHope. I'm sorry, I'm looking at the questions here. NetHope. It's not a firm. It's a large nonprofit. That's a nonprofit that is a consortium of 39 of the world's largest nonprofits. And you can look at it at www.nethope.org, N-E-T-H-O-P. I'll put all of this up so that you guys can use them because I'm running out of time. So those are the ways we take to market. So you can see how it's not just about instruction and innovation. It's about the immersion. How do you take it to market using social enterprises, nonprofits, and eventually corporations as well that we need to take it up. So, and we will absolutely, very good question. Why don't we work with designers and social scientists? Even though the Frugal Innovation Lab is in the engineering school, many of our projects are with, for example, science students in public health, social scientists, looking at the empathize part particularly uses social scientists. And we very much work with social scientists, both in the field, but with also students. Many of our students who go out through the Global Social Benefit Fellowship are non-engineering students, or they are a mixture of engineering, business, and social scientists. So I think the questions coming from you guys are great. And by the way, we don't have all the answers. Of course not. We're a fledgling organization, so any inputs from you and ideas from you would be greatly welcome. Just continuing on how you might connect this into, like you take an M-Farm and you might connect it into buying and selling using M-PESA. All I want to say is that mobile money is getting to be big in the rural markets, and it's getting to be very, very important. I'm seeing that in huge amounts in transactions happening outside of the normal banking world. For example, in Africa, in Kenya it started, and now M-PESA is in many countries. It's also now come into Asia. And I'm also seeing not just deposit and withdraw money, transfers money to users and non-users, paying bills, buying airtime, or being able to purchase mobile time, but it's almost becoming like a branchless banking service that doesn't even use the banks. And it's like and I think we need to look at regulations and stuff like that. But right now, more than 60% of the transactions in Kenya are outside of the Bank of Kenya and happening through mobile money. The other thing I'm starting to see is that mobile money is also going into barter trade. And it's like going back 50 years where we had barter trade, and talking about use of social scientists in looking at these kinds of transactions. I think it becomes very important to model behavior and look at design thinking from that point of view, because people are starting, like I see on this mobile money platform, there are many of those, Kopo and things like that, where they're putting on products. I want to sell, so many bags of seeds, and I want to buy. I'm not sure I've seen a cow traded on barter trade, but I've definitely seen many products like worms. When they have brackish water, you put worms into it that eats up the salt and things like that, and those are traded. I've seen them do barter trade with that. The other interesting thing here is M-PESA is operated not by a bank but by Safaricom, a mobile network operator. And so we have to really start looking at the design of these solutions from multiple constituents, because here there's a mobile operator who's operating it, who's not a bank, who's not classed as a deposit-taking institution, and yet they are operating those services, and then people in the rural areas, and now even starting to come into districts and towns. So interesting way that is changing. Google Wallet in the U.S. Can have a lot of impact in future years. Let me go on to one that we worked on that I feel very good about, and that's Fair Trade Calculator. Mobile solution, a senior design team worked with World of Good and developed a mobile tool to help piece rate workers calculate fair wages. And it's a NOKIA mobile tool, not a smartphone. And it can be a smartphone tool for buyers, but for the workers, it's a simple, what's called a function or a feature phone. And there's a web interface for the World of Good to measure the impact. This particular one has received a lot of attention recently for very sad reasons because of what has happened in Bangladesh. But we're getting a lot of interest in the kinds of things that this particular application, in fact, we've been approached to see if we can take it to fair trade wage calculations, that companies can look at that when they're working with garments, with retail, etc., so that there is a place where companies can go to look at a fair trade wage calculator and to judge whether a particular subcontractor of theirs is meeting it or not. I believe that we'll start working on this in the summer, and anybody who has ideas on this would be greatly welcome, because this is the group, Engineering for Change is the group from which all these ideas can come, and we'd love to partner on this. This is more a field level, the Energy Made For and in Uganda. It's a field level social enterprise that we're working with, and is setting up a technology center, and it's more on the education and instruction side. And it's a technology center for a solar home system designed by two electrical engineering students who actually won an award for this from Santa Clara, as well as partnering with students from the Zamizi Solar Technology Lab in Uganda. And using technologies that are available in country, and this is where the green becomes very important. And the design iterations are field work is being done both in the U.S. and in Uganda and tested both there. And right now, and the final design will actually be manufactured, installed, and maintained by solar technicians in Uganda. And part of this is the socio-technical network. So look at this. This is the go-to-market, where it's not just a technology solution, but it's the training of the technicians to manufacture, install, and maintain them. And that will be done through it's almost like a little university or a training center, and we are actually working with them not only to have the usable and locally appropriate solar home system, but it will also help them to be able to set it up to manufacture, install, and maintain. Another important element of this particular one, so it's not as though the technology is something fantastic and fantastically new, and this is where adaptable solutions and appropriate happen. Here we're bridging the gender gap as well, because a number of the people, as you can see here, will be women, and it will create women micro-enterprises and women micro-entrepreneurs. So this is a sort of I call this a total eco solution, whereby there is the technology, there is the go-to-market, there is the training, the education and training, and the setting up of the micro-enterprises to be able to do this. And this is going to be a multi-year project. There will be another group of students who will be carrying this on for the next year. Okay, I know I'm pretty close to running out of time. This is a social enterprise we've worked with, and I won't spend a lot of time on this because it is actually a for-profit social enterprise. But we worked in Santa Clara University. They went through the Global Social Benefit Incubator, and they came in very early in the program, and they are about providing HUSK power so being able to take create electricity from HUSK power, or from husks, rice husks. And there are 10 to 12 countries in the world where there's a large production of rice husks. It could be used for other husks as well. And the technology is about the conversion of that to power. And they actually they're looking at installing 3,000 plants and providing this to 10 million people on a village-by-village electrification. But through this, they're also creating more than a large number of small entrepreneurs and jobs within the communities, because when you get power into a community, you can use that to power a rice mill, and thereby taking the rice to the market, the rice, the actual, not just the rice itself, but taking the milled rice to market. It could be a variety of these things to be able to maintain the systems, to provide other kinds of services using power, not just have a light, but it could be mobile phone, charging services, and a variety of other things. So this is one where the technology is important, but the more important part of this case study is the scaling, the distribution, scaling, and sustainability model. For example, the output of this, when the rice husks are all converted, there's the char that comes out. That is used also to make some local products that are sold, so that the total waste that is left behind is fairly low. Somebody asked, what is husk power? I would encourage you to go look it up. It is conversion of rice husks with a technology that has conversion that into electricity. And I can again put up the information about all of these. I will provide you with case studies and with the URLs or little case studies that we have on them. Many of you may have heard about We Care Solar. They've been written up a lot, but they actually were incubated and started up from Berkeley and started up in Santa Clara, and they're out in the field. So it's being able to provide in a suitcase emergency power through solar to be used in an emergency room, and now it will also be extended to be used into refrigerate, blood, and a few other things in emergency room, not just to provide power. We have worked with them from the engineering school and from Santa Clara in 3 different iterations, and it's been, I really hope that, again, this is one example where the technology may not be, some new research, like stem cell research kind of technology, but the putting together appropriately affordable, accessible, and being able to install the solar panels, to train them on people, to make, there is now the 3rd or 4th iteration of the solar suitcase, and having the simplicity, designing a system, it's a 50 amp modular system that can be designed for expansion and can maybe accommodate 200 watts of solar panels, and including a battery so you can preserve it, because, solar power is not available everywhere. And having one switch that turns on the system and one that turns on lights and energy devices, little things like that may seem to us becomes very, very important for it to be appropriate. And you don't need an experienced solar technician. So that is part of the design parameters, that it has to be easily installable, and there are no such things as, well, you can call the call center for support. That just doesn't happen in these places. This is one we haven't worked with, but I wanted to share it with you because I just don't want it to be what we've worked with. I thought it's really cool piece of technology that's being used, and it's an iPod-assisted orthopedic surgery navigation tool for knee and hip joint replacements, and it is one of the most, for me, when I look at it and being able to use the iPod to guide physicians through or surgeons through, so the accuracy of the replacements are much better than they are now, because 30% of the issues with especially hip joint replacement is because of the little tiny inaccuracies, and that's where the recovery becomes very hard. There is a question as to how sustainable is all this technology, and I would say that some of it is really sustainable and scalable, that HUSK power has grown into many different countries, and M-PESA I've already mentioned, and there's some great examples of really scaled solutions. But some of that, I think the work that has to be done is in distribution models and scaling. And sustainability is also happening well, where people are using local materials and green materials. But I don't want to come across as all of this is something that's, really proven and in the future. But, that work is all being done. I think there is a lot of work to be done, and that's why we work with people like Engineering for Change, because that's where we can learn these things. I will go through, I have maybe, I think, like 5 minutes left. Is that right, Elizabeth? And so this is one that is in very early stages. It's a remote cataract diagnostic system, and we didn't, the technology for it was actually developed in MIT Media Lab called CATRA, and so we're just looking at the technology and seeing if it's applicable. There's a large number of millions of untreated cataracts and 700,000 cases of blindness in Mexico, and SALAUNO was founded in 2010 as a social enterprise in the field, and they asked us if we could help them with researching what's available in the market in cataract diagnostic systems, because they can't afford doctors to go to rural areas, and that's why the cataracts, one of the main reasons why it doesn't get fixed, because they can't detect it. And so this would be what I call avoidable blindness. Very early stages, the work we did, and why I put this up as an example, was not so much in the design of the technology, but really researching what was available in the market, what kinds of technologies, and we came across this CATRA, but it's in very early stages, and so We're just working on what the solution may be, and I wanted to share this with you again in case there are examples out there, of help that that people may want to work on some of these projects with us. And also to share that students just don't do technology work. They're also looking at what's available out there that can be adapted. And that's an important part when we're dealing with frugal innovation and engineering. So the last one is very close to my heart, and that is I work, so part of I have two hats. One is with the Frugal Innovation Lab, and the other is in the field. My husband and I have a social enterprise. We have two organizations. One is ANUDIP, which is a nonprofit, and that does skills development for youth, rural youth and women. And if you go to for rural youth and women, particularly minority women, marginalized people, and brings them, trains them on English, workplace readiness, and IT livelihoods, and actually works with employers worldwide. We work right now in Eastern India and Bangladesh, and we work with employers to be able to make them market-aligned skills training. That means we find out what the needs are, align the training. So the outcome is 80% of the people we've trained about 18,000 people, are actually in jobs and earning 3 times their family income. So that's sort of the outcome we want to get to, and they become part of the new economy. And an important outcome of this for us as an organization is that we started to come across communities of people that couldn't travel, or we wanted to avoid urban migration. So we started setting up IT or web project centers in the district towns where the people we were training, the rural youth and women, could come in and work. One such center was in an all-Muslim area of 700,000 Muslims, and it's an all-Muslim girls center. And they are doing amazing projects for customers, like web-based projects for Amazon, CATRA, Spot Crime, etc., worldwide, Catholic Relief Services, and are doing projects in XML conversion, digital publishing, ebooks onto Kindle, and a variety of things like global service desk. And to me, I'm quite amazed that people who have never seen a computer before, never had a bank account, that these people are working on these kind of projects. And it is the dream of IMERIT, and MERIT is mass employment through rural IT, that we make this a smart sourcing where it could be a group of students who are from a very low-income neighborhood, like in the Bronx in New York, where we have trained them in market-aligned skills. It could be teams in India. It could be teams in Kenya. And then that smart sourcing becomes a way that work is done for anybody anywhere, by people anywhere, through technology platforms. That's the dream. We're not there, but we're definitely working with people to be able to do it. And I want to end on this picture, which for me is our first group of women we worked with. And one thing they said, before ANUDIP, I didn't think I could dream, and now I'm dreaming. And it's not about ANUDIP or IMERIT. It's about the work that people are doing, like the people involved in engineering for change. That's the change, the transformative social change that you're looking for, and using as many of our skills and our experience, but also our empathy to be able to do this. And at this point, I will stop because my time's up and I'm being signaled.
Thank you so much, Radha. Thank you so much. This is a really inspirational note to end on. I would like to now open up the floor, so to speak, our virtual floor, to any questions and answers. And again, a reminder to please use the Q&A window located below the chat window to ask some more questions. And thank you, Radha, for taking some of them as we were rolling. In this case, we have one that's come in regarding the definition of sustainable solutions. What is that definition? Was livelihood as part of your lecture title, this individual presumes that you're also looking at social sustainability. How do you know whether something is sustainable? Many so-called sustainable solutions in the development sphere. I unfortunately cuts out, but let's just leave it as how you know whether something is sustainable.
Wow.
It's a tough question.
Amazing and tough question. You know, we have really put a lot of thought into this and done a lot of reading on what is sustainable. So it's a simple thing to say it's financially sustainable, which is your, single bottom line. Then you look at what is socially sustainable, which is called double bottom line, and then environmentally sustainable, which is the buzzword is triple bottom line. But without looking at the buzzwords, when we look at sustainability, of course we want to have an organization that year after year is totally dependent on grants to be able to do the work. Because what happens is you can never scale, you can never plan for things. So financially sustainable, having an earned income model, those kinds of things, and having the ability to plan, to scale, those become very important, which takes us to things like hybrid business models. So, but it doesn't have to be just a hybrid business model of nonprofit and for-profit social enterprises. It could be many different ways, but financially sustainable is one. I think that is the easier one because there's all kinds of ways of horizontal capital aggregation that you can do at different points. You can get, you can have debt funding, all kinds of things. But earned income, for me, and I'm just talking about my own view of this, becomes very important, an earned income model to be sustainable. The second one of social sustainability is a little harder to measure, but I can share with you what we look at. We look at social sustainability in the short term, mid-term, and long term. A mid-term example may be that the marriage age of the women we work with is increased by 2 years, let's say. I mean, to us, that is pretty transformative in the community, in this particular community we're working with. It could be that all the women that we work with and their mothers have bank accounts. That becomes a different kind. But social sustainability comes very much from the viewpoint of how you look at the changes you're making in the short-term, medium-term, and long-term. And long-term transformation, the short-term transformation, it could be things like more women have voter ID cards. But sustainability, I think, in a societal sense, is broader than that, and this is hard because it becomes a way that you partner with government, with society, with corporations, and for me, all sustainability has to make business sense. Without business success, without it being of success to business, I don't think we can really scale, and without scalability, sustainability is hard. I know that's a sort of a long, drawn-out answer, but I'm sorry I can't give you. I'm not brilliant, and I can't give you better answers. We're still working on this.
Actually, I think that's an answer that is multi-layered and reflects, frankly, the work exceptionally well, because this work is so multifaceted, and the engineering, we had recently an article on engineering for change that was titled "Engineering is the Easy Part." Not to, of course, undermine the technological development and the amount of value that technological solutions bring to this work, but certainly it is a very complex kind of solution that we end up developing, which includes these business aspects, and sustainability is so incredibly challenging in terms of monitoring and providing any feedback on success. So I thank you for that fantastic question, and of course thank you for that really comprehensive answer, Radha. I do apologize as we are approaching the end of our webinar, and I went ahead and I put up the slide that indicates where you can get some more of your questions answered if they haven't been answered already, as Radha is doing amazingly going and actually tackling them on the fly. I will ask one question that hopefully will have a shorter answer, which is, There's been a little bit of debate here around the graph that was shown on slide 10, and perhaps, the lab, Elizabeth and Radha can provide a little bit of information, even a URL to link to the original economist graph, so that folks can analyze it on their own time and get a little bit of understanding of why the lines are mirror images of one another. And the last question I have is regarding the size of the Frugal Innovation Lab. How big are you guys at this point? It seems like you have tremendous numbers of projects, and I think it would be lovely to know how big are you? Are you guys a little group or a big group, or it's amazing the amount of things that have come out of this lab?
Well, this is a perfect example of how it's as big or as small as it can be. It's actually because we have many faculty members from the School of Engineering and other parts of the university are part of it. It's sort of it's a lab that has a small group, core group, and then we work with the faculty and the projects, and you will see students in there all the time working on projects with us. So at any point in time, there may be, 30, 40 people working on projects. And when we had our Frugal Open House, we completed 1 year in April of the lab itself. We had an open house, and we had 250 people attend and about 22 projects displayed. But most of it is collaboration and the way we work together. And so there's a small core team, and then we work with all of these people as well as with corporations.
Which just goes to show how critical.
It's small and it's tiny, yes, but it's most things these days you can really, the way to scale is not to create the numbers of people within your own organization, but to really build it through collaboration.
Couldn't agree with you more. At E4C, that's exactly what we're trying to encourage, and certainly this highlights the importance of multidisciplinary collaboration, the fact that we need our technical folks, the engineers, the scientists, to work together alongside business professionals, social scientists, and other groups to ensure these wonderful sustainable solutions. So with that, I would like to wrap up today's webinar, and thank you all for attending, and certainly thank you, our presenters. Thank you to Radha and Elizabeth for working together and pulling this tremendous presentation together. For those of you who are interested in now getting some credit for having participated, on the screen now you will see the PDH code and email address that you should reach out to in order to get your PDHs. If you have any questions about the webinar series, please feel free to email the webinar team. And finally, don't forget to become an E4C member to never miss another webinar announcement. We'd like to wish you a pleasant day, an evening, or night, and look forward to seeing you the next time. And if you have any suggestions for future webinars, don't hesitate to let us know. We are so excited to continue this webinar series and grow it along with your support. Have a great day, everybody. Thank you to all, and we will, quote-unquote, see you on the next webinar.
Thank you.
Thank you.